Hello, this tutorial is about a mathematical expression parser called Mathos Parser, which is written in C#.NET and is based on .NET Framework 4.0. So this mathematical expression parser allows you to do a lot of stuff. You can add your own operators, you can add functions, and you can define constants. And those are just some of the features that are available in this parser. Before we do something else, it would be really nice to just look at the product page. So if you open the browser, type mathosproject.com. The link is provided below this video. Just put your mouse above product, scroll down to Mathos Parser, and as you get another menu here, you have to press project page so that you will be redirected to the codeplex.com page of Mathos Parser. Here we have two options. You can either download the library, and this will basically allow you to use the mathematical expression parser in all projects that target .NET Framework 4.0. So basically, you can include it into Iron Ruby, Iron Python, Visual C#, Visual Basic, F#, and a bunch of other languages that target .NET Framework. This is one of the options. The second option is to just press the source code tab and to then press on the download link so that you get the actual source of this project and extract this document, and then you can just copy, because as you can see, once I open this file I will have the actual source of this parser. So if you would like to add some modifications, if you would like to change something, adjust it, and so forth, you have the actual code to use and to modify of your needs. However, that's not what I'm going to do in this video. I'm just going to go to the home page again and download the actual library. So just press the Mathos Parser download link. Take some time, and once this is done, you will get a zip file, and here we have the library. So now we can close this page, and this and this. So now we're going to look at how to include this library into Visual Studio 2010. This works for 2012 as well, but my choice for today is 2010. So say my favorite language is C#. So I'm going to create a C# project. Of course you can choose to create a Visual Basic project and F# project, and as I mentioned before, any other project as long as it targets .NET Framework. So I'm going to press it C#, and here you have a lot of templates you can use, but I'm going to choose the console application template. This will call, or the name doesn't matter here, I think. So press OK. And now we have to extract this library. I forgot to do that. We copy the path of this library. Copy. And we press right click on our project, press add reference, go to browse, and once you're here you just paste the path and include the library. And now I have to return to the product page. On the product page, or the project page, you have, and if you go to the Mathos Parser, you have some of the examples that I'm going to show you today. One of the things you can do is to add operators. The second thing is to add functions, and you can as well do lots of stuff with those functions, and then you can add constants or variables. But just to show you how this actually works, I'm going to add a decimal variable. So decimal, we can call this result. And now we have to press Mathos and then Parser, and then we have to parse the actual expression, which is this can be 3 plus 6. This is one of the examples of how you might type an expression. Of course, you can have other complicated expressions, but I'm going to restrict myself for this expression. So I'm going to write console write line, then I'm going to type result, and then I'm going to once again type console read line, so that I'm going to pause the application and allow us to see the actual result. And we've forgotten to do one thing here. This is a dot Mathos parser. We have to I forgot to mention this. Mathos parser is an object, so you have to declare it as an object. So it's not the shared class, or a static class. So we have to type is Mathos parser, and then we can enter name. I'm going to call it parser equals new Mathos Parser dot Parser. This is how you can define it, and this is by the way a namespace. You can, if you don't like this long path to the actual object or to the actual class, then you can just add a namespace. And now my mistake in the beginning, but now we're going to do this the right way. Now you can type parser and specify parser dot parse. That's one of the options. So 3 plus 6, or 3 plus 5 this time. So let's see what happens. We press the run button and we'll get 8. And this is what we actually want to get. Okay, this was probably too easy, and let's add some brackets. So why not 3 plus 5, and here inside we write 8 plus 1. So what will this be? This will be inside the brackets. We'll get 9 times 5, and then plus 3. Of course, it's going to be 48. So as you can see, Mathos parser allows you to plug in an expression, and it will basically do everything for you. It knows the rules, what should be executed first. So like, for instance, if I would do something really complicated, something really complex with brackets and so on, it will understand these notations and give you the answer. This is one of the benefits. But another cool function I would like to show you is how it's possible to define your own functions, or your own operators. Later we're going to look at how you can add your own function. But this time we're just going to restrict ourselves to the operators. I'm going to just go to the project page. I'm going to copy the code, and once I've done that, I'm just going to go into the this project. I'm going to paste the code. Oh, wait. This was, I have to copy it again. This was correct. And this we should include afterwards. So here we just need to remove the definition of Mathos parser, and we need to remove that. So basically we're done, and this is the code I've added. So I'm going to select it. This is what I've added. I've modified it a bit, but this is what I added to my code. So basically the first thing you have to do is to access the operator list, and in this list you specify in what order these operators are going to be executed. So this to the power of sign will be executed first. So if it sees this sign, it will execute first. So here you can decide in what way your operators are going to be executed. So, and once you're done with this step, you have to assign this operator a function. Basically what this is going to do when it sees this operator. One of the things is to create anonymous function. And basically, as you can see, this is one of the ways. You can of course write lambda expression here, but I'm just writing an anonymous function using delegate. I'm entering number A and number B. So, but that's basically what you are going to get. And then you have to perform something. You have to do something with those values. And in this case, I'm going to use a built-in feature in .NET Framework 4.0. That's math.power. So basically to the power of. And it's going to do the thing for me, and we will get hopefully something that is going to be working fine. So why not just try an example? So 3x, 3 to the power of 2. And now we're going to execute. So what will this write is actually, this will basically give us 9, and that's what we want to get. That's the result we expected to get. So, and of course, if I would like to add my own operator, so why not just add a new operator? Let's be creative. So let's just create, like, what should I say? A dollar sign, And if we have a dollar sign, so we go to the operator action, we define the dollar sign, because we now have defined the dollar sign in the list, and then we now have to add an operator function, or action in this case. And what we are going to do then, so if we get 2 values, what we're going to do then is to take 2 times the first value plus 2 times the second value. Kind of nice operator, I think. And then I think we are done. So, or why not just take 3? Okay, I'm going to modify this a bit, and what should we say? We can write 5 and something easy, 3. So basically, if I remember correctly, so $5.3, this will give us, so 5 times 2, 10, plus 3 times 3, 9, so hopefully we'll get 19. And yes, that's what we get. And you can add as many operators as you like. You can come up with anything. You can create a percentage sign. You can do anything. As long as you pass in 2 variables. In this case, number A and number B. So you have to have a 5 and then you have to have a 3. So you have to have 2 different variables. This was about operators. But now let's look at a much cooler function, and that is, or a much cooler feature, I would like to say, and that is how you can add custom functions. One of the ways to add a custom function is to, so I'm going to copy a part of the code at the page, and this works with logarithms. So I'm going to remove my operator invention here, and I'm going to replace this with the local function variable. So here basically I'm accessing local functions, and then I use add. What this does is that it declares a function, in this case it's log, and it declares an array of decimals. And then we have the function itself. So what I have done in this function, I should probably have new results here. So decimal, let's remove this, decimal A will be equal to, and now we have to execute parser, again parse, and we can write log 3. This is the first thing it's going to do. So if the length of the input, so basically input stands for the arguments, and you can send unlimited amount of arguments to a function. And in this case, this function will get this array of parameters, and then it's up to the function itself, or basically up to you, to design what will happen if different values are set in that particular function. So I've written here that if input, so basically if we have one parameter, then we're basically going to take log in log 10 basically. So let's see what happens. And this has to be changed. This has to be changed to A. 1.09 seems to be correct. Now what we can do is to look at the second part of this function, and that is if we have two parameters, we're going to look at the first parameter as the what we want to take log of, and the second parameter is used to specify the base. So if I'm not willing to use the base 10, which is standard here, or default, then I'm just going to type that I want to use base 2, for instance. And I'm going to execute this. We get something different. So I can, just to see that it works, I'm going to type 2 here. So basically 2 to the power of something equals 2, and obviously we'll get 1. So it works. And the last statement is that if we don't have any parameters at all, so basically if someone would have given me log without any parameters at all, then it would have prompted an error, as we saw here. It would have prompted an error because we should have a specific amount of parameters, so it should be at least 1. So let's try to look at how you can add variables. So variables are really simple. So now we've been dealing with functions, and I could have probably, as an example here, just to modify, how would that work? Yeah, let's come up with something. Return the first value, so input 0 plus input 1. So it's going to add the parameters. So let's see how this works. 1 plus 2, and this will obviously give us 3. So this is another way of using functions. This is basically how it works. But now let's look at variables. Variables are also simple because, and it's even really easy to add them or easy to declare a variable. And for that purpose, I'd like to just show you another part of this function that you can use. Instead of writing parse, you can write programmatically parse. And in this case, I can enter an expression here. Let, and this is really simple, x be equal to 3. Now, if I would ask, so if I would just type decimal b and ask myself, or ask the parser, and we don't need to use programmatic parse anymore, we can just use parse, because now we've saved into the local memory, or into the parser, that x is equal to 3. So now if I type x here and execute, I'll get 3. If I would type 2x, I would get 3. And this is important to because the thing why this showed us this value is because I've forgotten to write out b. So I mean, I forgot to write console write line. I'm sorry. Now we have to type console write b as well, because in the previous module here, when I executed, now I get 6. But the thing is, when you execute programmatic parse and when you assign any variable a value, the programmatically parse function is going to return the value that you've assigned that variable into, in this case, variable a, and then it's going to print it. So then you have to create a new variable, and then you use the parse function, and now you can deal a little to work with the variable itself. So 2 in this case, and then the x, and now we get something that we want to get, that's 6. So there are a lot of stuff you can do, and especially, so we've been looking at, in this tutorial, we've been investigating some of the functions that are available, and we've been investigating custom operators. We've also been looking at how to create custom functions. So, like, if you want to have like your own function or define a specific function, or how to pragmatically add variables. There is also an example, which is actually, because Mathos Project, which is the publisher of Mathos Parser, it's a community, so it's possible to contribute with some code snippets and so on. But there is some examples that have been made using Mathos Parser, so using this library that I've been using in this tutorial to create a web application. But today it's not working because it's currently under development stage, but still after a week you'll be able to use the Mathos Parser online, but for the moment it's under development. However, thank you very much for watching this video, and if you have any questions, just type a comment or go to the home page, and here I think you have different options that you can look through, but everything is available here on the page. But thank you very much for watching, and hopefully you'll like to try out how easy it is to use Mathos Parser to parse simple and advanced mathematical expressions. Thank you very much, and have a nice day.